Hello and welcome everyone to this new video about generative AI. In this video, I will be talking about the llama.cpp. In the previous video, I showed you a little bit the site of the llama.cpp, and we used one script from the llama.cpp to generate a GGUF file, or more precisely, to convert a Hugging Face model to a GGUF file. In this tutorial here, I will show you how to clone and build the llama.cpp. Then we will be using this GGUF file, which we created in the previous tutorial, to create a model in the Ollama. And then we can run this model in Ollama and ask it questions to get answers about our DOA estimation algorithms like music and Esprit, which we fine-tune our model based on them. Finally, I will show you how you can use the llama.cpp in Python, and for that you only need to use pip install the llama.cpp, and you don't need to clone and build the repository. Let's start by cloning and building the llama.cpp. So this is the repository of the llama.cpp, which we've seen already in the previous video. I will go to code here and will copy this link. And now, since I'm using Windows, I will open a PowerShell, and then I will navigate to the folder where I'm saving the files for this tutorial. So this is the path I'm using for that. And now the folder is empty, as you can see here. So let's do git clone and the copied path. So now if we did ls, you can see now they have this folder llama.cpp. So let's step into this folder. And let me put the PowerShell side by side by the web page, because we will follow the instructions from the web page. So now let's go to the build, then how to build. So as you can see, we already did the clone and we already stepped inside the folder. So now we need to run cmake -b build. Remember, as I said in the previous video, for that you need to have the cmake installed. So you can download cmake from the cmake website. So I also have Microsoft Visual Studio 2022. So this is the link for the Microsoft Visual Studio. That would be my C++ compiler. So if you are using Linux, you can still install cmake using apt-get, for example. So if you are on Ubuntu, and you can also download G++ and other packages or other compilers using apt-get. And now let's run the cmake command. So I will copy this command here and run it. So it's done. And now let's build the release version using this command. So you can see now here the different EXEs are being created. And also here we have them in ggml, dll, and the llama.dll. So it's finished. The build is successful. And these EXEs, as you can see here, it's in the build path. So here we put the llama.cpp, then we have the folder build, bin, and release, since that's what we configured the build command for. Now let's go back to the first page of the llama.cpp, and let's scroll to this section here, llama CLI. You can see that we have a command line interface where we can run GGUF model. So let's use that. So the llama CLI interface is here in this folder. So we can now either run it here from this PowerShell, or we can also use the PowerShell inside VS Code. Let's do that now from here. So we need to go to the build, then releases, then bin, then release. Let me clear. And now we can run the command. So llama CLI, and then we need to give the path for our model. Let's get this path. So in video 8, we saved the model here inside this DOA merged. So it's this file here. So let me copy the path. And then we need to define -m and then the path, and let's run it. And now it's already loaded. We can ask about our DOA estimation algorithm. So for example, for Esprit. So I asked what's Esprit for DOA estimation, and as you can see here, we got our answer that it used the shift invariance property of the sensor array. Let's ask for detailed steps for that. Yeah, so it gives us a detailed output. So again, it started here by a simple definition of Esprit. It's subspace-based method, and it used the shift invariance property. The main steps are the sensor array definition. So it's assuming now a uniform linear array. Of course, Esprit works for more general array structure than this, but that's also okay now for ULA. Yeah, and then it's talking about signal subspace selection, which is really important because the Esprit algorithm really need the signal subspace, while the music algorithm actually works using the noise subspace. So that's really also a correct information here. And of course, we get these subspaces using the eigenvalue decomposition. And then, yeah, we need the shift invariance property and so on. It's giving us really a good answer. Let's ask now about the music algorithm. So what can you tell me about the music algorithm, and also give us a correct definition? So it's multiple signal classification, and it's a subspace-based method, and yeah, we need the eigen decomposition and so on. So you can see we are using this GGUF model without even needing Ollama for that, just by using llama.cpp. I also started this llama.cpp without GPU support. So it's important now to note that the performance that you have seen is actually using the CPU. So let me show the task manager, then the performance here, and let's focus on the CPU performance. Let me make this a little bit smaller and put it to the side here. And I will repeat the same question as before, so the detailed step-by-step question, because that gives a huge output, and then we can monitor this performance here while this output is being given. So let me run, and notice that now the CPU is went to 100%, while for the GPU you can see that they are not used. So really now we were running using the CPU, and I did not fast forward for that. So that's really a good performance, and you don't even need a GPU to run a small LLM with 1 billion parameter or 3 billion parameters. I think I even tried like 7 billion parameters. It was okay. Yeah, you really want to get to these huge LLMs with like 400 and so on to really experience a slow performance. So that's it about building and using llama.cpp. Now let's see how we can use this GGUF model in Ollama. So let's close this model and let me clear the screen, and let me first do an Ollama list. And you can see that I already have something with the OA here, so I will delete it. So now it has been deleted. Notice also that I have this llama 3.2 with 1 billion parameter. So let me also delete this. So now I really don't have anything for this llama 3.2 1 billion parameter. I have this 3 billion parameters. I can also delete that, but that's okay. So what I did now, I just cleared everything so that you can see that we are starting really after installing Ollama, and then showing you how you can create an Ollama model using this GGUF file. First thing we need to do is actually to pull the base model. So since our fine-tuned model is based on the llama 3.2, we need first to pull this model, so the original llama 3.2. And for that, we use the command ollama pull, and then we put the name of the model, so llama 3.2 1b. We already did that in previous videos, but I will show it again here. So it's finished downloading. So let me tell you why I'm downloading this llama 3.2 1 billion parameter. We really don't need this model for doing the inference. We only need it to create a configuration file for Ollama. You've seen now using the llama.cpp, we only needed this GGUF file, and we were able to load and use the model directly. In Ollama, we need this GGUF file and an extra configuration file, and the configuration we have to write in this file is really the same as the one from the original file, and that's why I put the original Ollama model here, because now I can run some Ollama commands to get those configurations. So let me show you the command for that. Let's first clear, and this is the command. So we have Ollama show, so and then we put model file and we give the name of the model. So we need llama 3.21 billion parameter, and press enter, and here you see we got all the configurations. So there is basically here from, so this point to the folder where Ollama put this pulled model, and this is the only part actually we need to change later. And then you can see here we have the template, we have then even here below the licenses and so on. So what I want to do now is to save this configuration file to a text file, but for that let me step back to video 9, and let's do ls here. So we only have the llama.cpp. Let's create a directory and let's call it model, and then let's save this configuration file here inside this directory. So we run the same command as before, so llama show the llama 3.2, and then I have this larger than symbol to direct the output into a file here. So this will create a file for us called llama 3.2-1p-instruct q8 underscore 0.model, and this file will contain the text we've seen before. So let's run this, and let me do an ls, and you can see here is the file. And if I set cat for this file, you can see the text here, which is the same as the text we got before. Let me now go to VS Code. So what I want to do, I want to copy this model here, and I want to put it inside this model here. And you can see here we have our configuration file. So we need to change this from, and since we have the two files in the same folder, I only need to put here the name of the file, the GGUF file. And that's it. We can now save, and let me clear here. And now we can run the command for Ollama to create, and that would be Ollama create, and then we give the model a name, and then we have -f, and we should point configuration file. And that's it. Let's click enter. So when it's done, we can do Ollama list, and you can see here we have a new model which has been created or modified 5 seconds ago. Yeah? So this is our new model, and now we can use Ollama on this. So let me do Ollama run on our new model, and now we can ask about our DOA estimation algorithm. And as you can see, we get music as a subspace-based method for direction of arrival estimation and for Esprit. So we also get some answer, which somehow also comparing to music. Since this is a chat, so it's also looking to the previous question. And that's how we use GGUF models in Ollama. So let's go now back to VS Code. Inside VS Code, I want now to use this llama.cpp using Python. So let's create a new file. So first step is installation, and you can see here in Python, if you search for llama.cpp, you find this Python bindings, and for installing them, you only need pip install llama.cpp Python. Let's copy this command, and let me first make sure that we are using the correct virtual environment. We are using this environment here. So now let's run the installation. So installation is done. So I want to emphasize here that installing these packages using pip does not require cloning the repo and building it. So that's why I can come here to this llama.cpp, which we cloned and built in the previous step in the beginning of this video, and I can delete it. So this is not required, and I also don't want to upload it to the Git repository because you can anyway clone it from the llama.cpp. And now let's go back to this page for the llama.cpp. So we run this installation command, and if we scroll down a little bit, you can see here some examples on how to use it. So let me copy this first example here and run it. So for that, as usual, I will add a cell here. And before I run, we need to put the correct path here. So we have our GGUF file here inside this model. Let me copy the name and let's correct the path here. So it should be model and the name of our model. And here they are asking a question about the planets in the solar system. We could keep that, of course, and run. Also, here's the part for loading the llama.cpp. And then here's our answer. I think we can remove this part here if we put something like verbose equal false. And let me clear this here. Let's rerun. Now we only get here a small warning, and then we get our output. So you can see here in the output, we have the question and then the answer. So Mercury, Venus, Earth, and so on. Yeah. Let's now ask about Esprit, and let's rerun. And again, you can see here the question and then the answer. So actually we can output only the choices here, and we will take the first choice. And so this is a list which contain only one dictionary, and this dictionary contains this text here. So let's take the first element and the text. So I cleared and reset. Now let me rerun this, and now I'm asking about the music algorithm, and let me click Control Enter. And you can see here what's the music for DOA estimation, and it's telling us that the music is a subspace-based method used for DOA estimation for multiple sources, which is really a correct answer. So now if we went back to the llama.cpp Python binding page, you can see another example here for creating chat completion. Let me also copy this and try it. So let me add here a new cell, and let's copy the model from here and correct it here. Chat format, let's put 3.2. And then we have the question. And then as you can see here, we have messages. So we have the roles, and the role is system. And the content is you are an assistant who perfectly describe images. So for me, I will say an assistant who perfectly answers question about algorithms for direction of arrival estimation, DOA. And then here we see the role user. And let's put our question here. And now since I already defined the DOA here in the upper part, I don't think that we need it here. So it's enough to mention DOA. The model will know that we are talking about direction of arrival estimation. So let's assign this to output and then print the output and run. Yeah, so I forgot here to put verbose to false. And we have an error, chat completion handler not found. Let me clear. I think I only need to delete this here. And now let's rerun. And you can see here we got chat completion, different information. Then again, we have here choices, and we have message in the role assistant, and the content is about the music. So let's now, instead of printing the output, we printed choices, and then let's take choice 0. And then I think messages was the output. Let's see what this will give us. Yeah, so now we need the content, and that would be our answer. So music is a subspace-based method used for direction of arrival estimation. So that's how you use llama.cpp in Python. You can, of course, go through this page and see more examples. For example, how you can force an output format, or how you can set the temperature. Here also response format, and also calling with some tools, and so on. So that's it for this video. In the next video, I will show you another variant for running LLMs, which is llama.java. So I hope to see you in the next video. Bye.